In this video, we're going to run the Drainage Water Management tool. The Drainage Water Management practice adjusts the water table at certain times of the year via a control gate. So for example, if field access is necessary, say for harvest, the gate can be opened to allow unrestricted drainage. Or if you're in the midst of growing season, the gate can be raised, which will raise the water table and therefore the water available to plant roots. One control gate can influence the water table within approximately a half a meter change in elevation. The way the ACPF tool works is that they will only be sited within agricultural fields, that's the ISAG field equals 1, and if the field is likely to be tile drained, based on that tile drainage classification tool's results. The user can define the contour interval that is used. So one gate is suggested for a half a meter elevation change. If you were using a 1 meter contour interval, that means 2 gates would be suggested for that interval. And then the user can also specify either the percent of field that the interval must make up or an acreage of field. Alright, so we're back in our map document and let's run this tool. So we'll come over to this tool set, go down to Drainage Water Management, open it up, and we have 6 inputs that it's asking for. We have our field boundary feature class. We'll drop that in there. We've got this unfilled DEM, which is the new DEM. The drainage table has been automatically added. It's asking for a Z factor, so we'll do that at 0.01. And then the user specified contour interval in meters, I'm going to leave it at 1. And then we have the choice of either supplying the minimum percent of field that the user defined contour must occupy, or optionally the minimum acreage within a field that the user defined contour must occupy. I'm going to go with the minimum percent of a field. You can see over in the tool help, it tells you that this percentage must be between 30 and 100%. This is a recommendation. But if you try to put in a value, say, oh, only 10% of the field, it says, nope, that's not going to work. You're outside of this range. But I am going to go with the minimum value of 30%. And then from this tool, we're going to get the one output of the Drainage Water Management polygon, which will show us the area that if this tool was put in, this is what it would treat. So we'll hit OK, let it go. So it's kind of interesting how this tool works. Below is an example given where we specified a 1 meter contour interval and that 30% of the field must be treated by that practice. So first off, the tool calculates the elevation range of each field, which can be shown in image A. That range is then rounded appropriately, and then the number of 1 meter contour intervals that can fit within that field is found, which can be shown also in image A by what it's equal to. The field is then sliced up by those contours, and then the slices are determined if any of those zones occupy more than the user-defined percent of the field or user-defined acreage. So in our case, do any of these slices make up 30% of the field? If it does, then that slice is flagged as an opportunity for drainage water management, shown in image C by yellow. As you can see, there can be multiple opportunities per field. This just simply means that more control gates would need to be installed. Alright, so the tool is just finished running, and it's not so really surprising that we don't have too many opportunities within this watershed for drainage water management, as most of it is made up of steeper slopes, and therefore most of these fields didn't have a flat enough portion of it to be ideal for this practice. But let's take a look at what we've got anyways. I'm gonna symbolize it a little bit just to make it stand out a bit more. And we can zoom in and take a look. Now within a single field, what sort of portion of it could be treated by this practice? You can see, for instance, this field a majority of it does get treated. And it's no surprise that most of these opportunities within this watershed are very close to the stream, just because that's where the floodplain would be located, and that floodplains are typically flatter areas. So let's take a look at the attribute table and see what we've got. You can see we have the field boundary ID that it's associated with. You could see then if certain fields had more than one opportunity. In this case, it doesn't look like any of them did. I don't see any repeats. And then we also get the contributing acres to that practice. We get the field acreage, so we could compare. And then the percent of field, since I specified that it had to make up at least 30%, we won't see a value lower than that. We do see that there are a couple that treat close to 75% of the field, which is exciting. You can take a look. Those do make up a large portions of those fields. And then, just in case you forgot, the contour interval that you specified is supplied. So here's a brief recap of everything we just went through.